So, have you ever really stopped to think about numbers? I mean, not just using them, but where are they? Are they real things? And if they are, where do they live? This is a huge question, a real philosophical mystery that people have been wrestling with for, well, for thousands of years. And today, we're going to explore one of the most powerful answers ever cooked up.
All right, let's really get into this. Think about it. You grab a pen, you draw a triangle, it's never perfect, right? The lines are a bit shaky, the angles are never quite a perfect 180 degrees. It's always an imperfect copy. But in your head, you know what a perfect triangle is. We all do. So where is that thing? Is it just floating around in some kind of idea space? That's the exact puzzle we're digging into.
And you know, this exact question, it kicked off one of the biggest debates in all of philosophy. And it was between a teacher and his own student. You've got Plato on one side, basically saying these perfect ideas, these forms, they live in this whole other higher reality. But then his star student, Aristotle, comes along and says, whoa, hold out a second. I think the answer is right here, in front of our faces.
Okay, so before we get to Aristotle's big aha moment, we really have to understand what he was arguing against. We need to look at Plato's idea, because honestly, it's a beautiful, elegant solution. It's so powerful, it's been influencing people for literally thousands of years.
So for Plato, the world we see and touch, it's kind of like a shadow play. It's not the real thing. And that imperfect triangle we draw, it's just a shoddy copy. A faint echo of the one true perfect form of a triangle. And that perfect form, it's eternal, it's unchanging. And for Plato, it's way more real than any triangle you could ever sketch on a napkin.
And this is the whole idea behind what we call Platonic forms. You can think of them like the ultimate master blueprints for everything. There's a form for goodness, a form for beauty, and yep, a form for every single mathematical object. It's a really clean way to explain how we can even think about perfection when we live in such an imperfect world. Sounds good, right? Well, it's got a few holes in it.
And this is where Aristotle steps in. See, he was a super sharp observer, a real logician, and he just wasn't buying it. He took a hard look at Plato's theory and started to find some pretty major cracks in the foundation.
And Aristotle, being Aristotle, didn't just say, I disagree. Nope. He showed up with a list. He pointed to 4 very specific, very tricky puzzles that he felt Plato's whole theory of forms just couldn't answer. First up, what we can call the problem of precision. Look at any circle a mathematician draws. It's always a little bumpy, a little wobbly, right? It's imperfect. But they use these imperfect drawings to come up with perfectly rigorous proofs. So, if the real math stuff is off in some other dimension, what are they actually doing here on Earth? It just doesn't line up with how math is actually practiced. Okay, next is the plurality puzzle. This one's a real head-scratcher for Platonism. So many geometry proofs rely on having 2 triangles that are identical, but are still 2 separate things. But wait a minute, if Plato's right and there's only one single perfect form of the triangle up in his ideal world, how can you have 2 of them in a proof? See the problem? You can't have both.
Then there's puzzle number 3. Separability. Here's the deal. Mathematical truths feel eternal, right? 2 plus 2 will always be 4. But physical things, they rust, they break, they disappear. So how do we get timeless, perfect knowledge from these temporary, messy objects? Plato's answer, that the perfection is in another world, doesn't really help. It just kicks the can down the road and raises a new question. Okay, so how do we, stuck here in the physical world, ever access that other world?
And finally, we have what you could call the non-revisionism puzzle. Aristotle's whole vibe was, look, any good theory about math has to respect what mathematicians actually do. And this quote from him just says it all. It is unqualifiedly true to say of the mathematicals that they exist and are such as mathematicians say. Basically, you can't build a philosophy of math by telling all the experts they've got it completely wrong from the get-go.
So, with these 4 puzzles on the table, Aristotle didn't just tear down Plato's idea. He did something way more constructive. He built a whole new theory, a totally revolutionary alternative that was grounded, it was practical, and it didn't need you to believe in a whole other dimension.
And this is Aristotle's big, brilliant idea. He says, the answer isn't in some other world. It's in having a better way of looking at this one.
We don't need to invent a whole new reality, we just need to learn how to see our own world like a mathematician does.
So, how does this actually work? Well, Aristotle lays it out in a pretty simple three-step process. Step 1, you start with a real object you can see and touch, like a triangle made out of bronze. Step 2, in your mind you just strip away all the physical stuff, its bronze color, its weight, its temperature. He called this abstraction. And then step 3, and this is the real genius part, you study the object qua triangle. You look at it as if it were only its mathematical properties.
This mental process of taking away or subtracting, that's what Aristotle called aphoresis. We just call it abstraction. It's like you're putting on a pair of intellectual filters. You're not discovering a new object in some other world, you're just looking at a familiar object in a brand new way, zeroing in on its mathematical DNA, you could say.
And that brings us to maybe the most important, most powerful little tool in Aristotle's whole philosophical toolkit, the word qua. In his Greek, it was hei. Think of it as a conceptual lens. It just means as, or in the respect that. It lets a thinker say, okay, I am looking at this physical bronze thing, but I'm only studying it qua triangle. It's this incredible way to precisely filter your own thoughts, ignoring everything that isn't about geometry.
And you know what? This idea was so powerful that it didn't just stay in the world of math. Aristotle realized that this whole method of abstracting things and studying them qua something was basically a blueprint for organizing all of human knowledge, all of science.
Yeah, this wasn't just about triangles anymore. He took this same logic and applied it everywhere, creating this incredible ordered structure for all the sciences. It wasn't just a big pile of facts. It was a system where the more abstract sciences could actually explain the more concrete ones.
He called this system subalternation, and it basically creates this beautiful, logical ladder of knowledge. So for instance, way down on a lower rung, you might have a science that just describes what's happening, like, say, the study of rainbows. But to explain why a rainbow forms, you need to climb up to a higher science, optics. And to get the fundamental proofs for optics, you got to go even higher, to the most abstract science of all, geometry. You see how it works? Each level up provides the why for the level below it.
And what's the very foundation of this whole structure? It rests on what he called axioms. These are the foundational truths, the starting points that are so obviously true you don't even have to prove them. You know, like the idea that if you take an equal amount from two equal things, the parts that are left over are also equal? These are the absolute bedrock, the starting blocks that all scientific knowledge gets built on. Okay, so after that whirlwind tour of ancient Greek philosophy, let's bring it back to today. Why does a 2,000-year-old debate still matter? What's the big deal? Well, it's because Aristotle gave us a way to keep the abstract world of math tethered to the real world we live in. So what are the big takeaways here? What did Aristotle really give us? He brought math down from the clouds. Instead of sticking numbers and shapes in some faraway mystical world, he showed us that math is a really powerful tool for understanding the world that's right here in front of us. With his ideas of abstraction and that clever little concept of qua, he neatly solved all of Plato's big puzzles. And in doing so, he gave science this grounded physical foundation, a legacy that absolutely still shapes how we think about knowledge today.
And that leaves us with one final big question to chew on. Is mathematics a discovery, or is it an invention? Are mathematicians like explorers, charting the map of some hidden Platonic reality? Or are they more like brilliant inventors, creating an amazing language to describe the world we can actually see and touch? Aristotle gave us his powerful answer, but it's a question that still challenges every single one of us today.